Hey guys, happy Monday morning. I hope that you had an awesome homecoming and that you are back and ready to get some work done this week. So today, obviously you have a sub. You should have picked up homework 2 on the way in. We're going to learn about the second derivative test. So the second derivative test is very similar to the first derivative test as far as like what you do, but it tells you about concavity. So that is a word that you should know from Algebra 2, maybe a little bit in Algebra 1, also in Pre-Cal. But concavity tells you how the function opens. So concave up, your graph is going to be up like a cup. Concave down is down like a frown. Okay, so up like a cup, down like a frown. Got it? Okay. So when your graph is concave up, f double prime of x is going to be greater than 0. When your graph is concave down, f double prime is going to be less than 0. Okay, and then the places where this concavity changes has a special name. Okay, it's called a point of inflection. Okay, and a point of inflection is x values where f double prime of x changes sign, which results in the graph of f of x changing concavity. Okay. So the first one that we're going to do, we're going to keep it super easy. We're going to just do a polynomial. So it's going to be y equals 2x3 plus 3x2 minus 36. Okay, you are going to find points of inflection. Okay, so first thing we're going to do is take the first derivative. So y prime equals, taking our 3, times it down on the 2, 3 times 2 is 6, x is now squared, plus. Next term, 2 times 3 is 6 again, but x is to the 1. Derivative of 36, that's a constant, is 0. From there, I'm going to take the second derivative. So, 6x squared, 2 times 6 is 12x. X is to the 1 times 6 is a 6. Derivative of x is going to go down to an x to the 0, basically goes away. Then from there, you're going to set that equal to 0. Now, I notice both of those can divide by 6. That leaves me with a 2x where the 12 was, and then 6 divided by 6 leaves a plus 1. Now, for first derivative test, these were called critical numbers. They are not called that for the second derivative test. They're called PPOIs. What that stands for is a possible point of inflection. Okay, so it's kind of like the critical number, but for the second derivative test. Okay, it's called a PPOI, a possible point of inflection. So 2x plus 1, my possible point of inflection is minus a half. Remember, I changed the sign on the 1, then I divide the 2 to the bottom. So number line test over here. Negative 1/2 goes on my graph. And then from there, I plug in a number bigger than that and smaller than that. So let's say that I picked 1. Okay, we'll plug it in here. 6 is obviously positive. Then I have 2 times 1 plus 1. Okay, well 6 is positive, 2 plus 1 is positive, overall positive. Left of 1, say I pick negative 1. Okay, well then that'd be 6 times 2 times negative 1 plus 1. That's negative 2 plus 1, so it's a positive times a negative, which is negative. Now, when you label your sign chart, be very careful. Okay, this is now f double prime, and it is telling us about regular f. So the first thing that I would do is say, okay, well, if f double prime is negative, that means come up here to the top. Remember, when f prime is negative, f is concave down. So I'm going to put a u like that. And then for regular f, I know that when f double prime is positive, regular f is concave up. So that means that negative a half is, in fact, a point of inflection. So I would put at x equals negative a half, f has a point of inflection. Because f double prime changes sign. Now, if you want to, you could say it changes from negative to positive. That's not wrong, but it's kind of unnecessary because, like, for mins and maxes, the order matters because it tells you if it's a min or a max. But for a point of inflection, the direction doesn't matter. So you can just say it changes sign and not indicate direction because it would still be called a point of inflection either way. Okay? Now, the other thing I want to do is just kind of like sketch a graph of this just to make sure that you understand what this would look like. So if I were to graph x cubed, okay, hopefully you know sort of what that looks like. Okay, your graph goes like this. Okay, we'll say like that. Now, obviously, it's not going to be exactly like that. That's a very simplified version. Okay, but what this means is that my inflection or my concavity changes at minus a half. So if I were to go to right here, that is where my graph changes. On this side, it's concave down like a frown. And then on this side, it's concave up like a cup. Okay? Now, if I wanted to find where this max and this min happen, I would have had to do a first derivative test. So remember, use first derivative test to find mins and maxes. Okay, but remember that a second derivative test tells you where the concavity changes. So before negative a half, my graph is concave down. And then after negative a half, my graph is concave up. Okay, make sense? Hopefully, yes. Let's turn the page and do another example, just like that. Okay, so number 2. Number 2, we're going to do f of x equals, it's going to be x to the 5th minus 3x to the 4. So we are finding points of inflection. Find inflection points is another way to say that. Really doesn't shorten it that much, but it's the same basic thing. So for inflection points, first thing I'm going to do is find f prime of x. So 5 comes down to the front, 5x to the 4. Second term, 4 times minus 3 is minus 12x to the 3. Okay, then remember that if I use this, use to find mins and maxes. Okay, but it didn't ask me for that, but if I needed that, that would be the derivative I would use. But for points of inflection, I need the second derivative. So 4 times 5 gives me 20, x to the 3. 3 times 12 gives me 36, x to the 2. And then from there, I'm setting that equal to 0. So I look at both of my terms. I have a 20 and a 36 here. It looks like I can take out a 4, and I can take out an x squared. So let's see what's left over. Out of my 20 divided by 4, it's a 5x left over. 36 divided by 4, that's going to leave me a minus 9. My x squared is gone. So my possible points of inflection are x equals 0 and 9/5. Okay, from there, are either of those double roots? Okay, because all these same principles apply whether you're using the first derivative test or the second. So when I see my x squared here is positive or squared, I know that that's a double root. And remember that for double roots, I can expect no sign change on my number line. So when I set it up here, I'm going to put 0 here, 9/5 here. And then I'm going to plug in a test point, but I know 0 should be the same on both sides. So 9/5, a little bit bigger than that, I could pick 10/5, which is the same as 2. So whenever it's a fraction, that's kind of how I think about it, is I want to increase the numerator, but to a number that can divide evenly. So if this is 9/5, I can go up to 10/5, which is the same as 2, plugging in here. So I have 4 times 2 squared, 5 times 2 minus 9. Okay, well 4 times 2 squared is positive, 5 times 2 is 10, 10 minus 9 is also positive, overall positive. Okay, between these guys, I'm going to go down from 9/5 to 5/5. So think about 5/5 is smaller than 9/5, and it's the same as 1. So I'm going to do 4 times 1 squared, 5 times 1 minus 9. Okay, well 4 times 1 squared is positive, 5 times 1 is 5, but 5 minus 9 is negative. So overall in the middle, it's a negative. Okay, let's say I wanted to pick smaller than that. I'm just going to go with -1 because it's easy. So I'd have 4 times -1 squared, 5 times -1 minus 9. This is going to come out to be positive in the front because I'm squaring the negative. But then that's a -5 minus 9 more, which is negative, which means it's negative here. Oh wait, and then remember we said that if it's a double root, I already kind of knew that that was going to be negative. Okay, now remember, this is a second derivative test, so that's f double prime. Well, then that tells me about the concavity of f. When f double prime is negative, f is concave down. When f double prime is negative, f is still concave down. But then when f double prime is positive, f is concave up. So what that means is my graph is concave down, concave up. Well, then I only have a point of inflection at x equals 9/5. Okay? So remember, x equals 9/5, we have a point of inflection. Okay, and it occurs because f double prime changes sign. That tells me that the concavity changes. That's the definition of a point of inflection. Makes sense? Hopefully, yes. All right, we're going to do one with a chain rule. So number 3, y equals. We're going to do 2x minus 6 cubed. Okay, so hopefully you realize that this is going to require chain rule. Okay, because it's not just an x in the power, it's a 2x minus 6. So this is my core. So when I take the derivative y prime, my 3 is going to come down to the front. My 2x minus 6 is now going to be squared times the derivative of the middle, 2x minus 6, derivative of that is 2. So my new first derivative, y prime equals 3 times 2 here is a 6, 2x minus 6 squared. So I just took the 2 from the back, the 3 from the front, and I combined them to make a 6. Okay, also right here I should have put that's y prime. Now remember, for a first derivative test, that would be great, but I need the second derivative. So y double prime equals, we're doing chain rule again, 2 times 6 here in the front, 2 times 6 is 12. And then the power on my 2x minus 6 is now to the 1. So you can put it or not, doesn't matter. But my core, 2x minus 6, has a derivative other than 1. The core of 2x minus 6 is 2. So 2 times 12 in the front gives me 24, 2x minus 6. And then I'm going to drop the 1 at that point because why would I put it? Okay, so from here I set that equal to 0. And then I notice from here that I can pull a 2 out of that. That's going to give me from the 2x minus 6 and x minus 3, which means that my PPOI, possible point of inflection, is x equals 3. Then remember from there I'm going to show my sign chart. 3 is the only number I'm putting on my number line. A little bit bigger than 3, I could pick maybe 4. Okay, well 24 times 2 is positive, and then 4 minus 3 is positive. Multiply two positives, get a positive. Smaller than 3, say I wanted to pick like 2. 24 times 2 is still positive, but 2 minus 3, this term, is going to come out negative. And if I have a positive times a negative, their product is negative. Label your number line, that's F double prime. That tells me about F's concavity. F is concave down, then F is concave up. Then remember from there, that does make that a POI. So I would say I have a point of inflection that occurs at x equals 3 because F double prime changes sign. And then remember, you don't have to specify the direction, but you can if you want to. That's up to you. Okay? All right, we have 2 examples left. Okay, so we're going to do one with a trig. Hopefully I can pull this. If you're not done, just ask the sub deposit, of course. Okay? All right, so this is number 4. Our equation is going to be y equals 2 sine x minus x. Y equals 2 sine x minus x. So, y prime, okay, what's the derivative of sine? Well, remember, snow cone, snow cone. So if I'm at sine and I go down, now I'm at 2 cosine x. And then the derivative of minus x is minus 1. Now, that's the first derivative. That tells me extrema. I want the second derivative. So the derivative of 2 cosine, I'm here, go down a notch. That would be negative 2 sine x. Now, the minus 1 here, derivative of that is 0. Okay, then from there, I'm going to let 0 equal negative 2 sine x. Then I'm going to divide by negative 2 on both sides. 0 equals negative, oops, negative 2's gone. 0 equals sine x. Okay, then from there, I need to think about what is going to make sine x 0. Well, if I'm doing my hand trig, okay, I'm going to try to fit my hand in here. Okay, so I need my pinky to be what I'm folding down. Because remember, sine needs to be 0. That means I need no fingers on the bottom. So I'm going to pick my pinky. There are 2 places that happens. X could be 0 or pi. Now, it could also be 2 pi, 3 pi, however many pi's you want. So let's restrict our question to be on 0 to 2 pi. So 0, pi, and 2 pi. Okay, those are the places that sine comes out to be 0. So set up your number line. Those are my PPOIs. And actually, rather than putting arrows on this, just to make sure it's not confusing, I'm going to use endpoints. So on this side, I'm going to put 0. On this side, I'm going to put 2 pi. In the middle, I'm going to put pi. So when you put arrows, it makes it seem like you're going to the infinities, and you don't want to do that. So from here, we're going to pick a test point. So on this side and this side, I need to choose a number. So here, I'm going to pick pi halves. That's smaller than pi. Here, I'm going to pick 3 pi halves. Okay, so these are my test points that I'm checking. Now, this is very important. When I put these guys back, I need to put them back in the derivative. So you'll notice that at this point, when I started solving, I divided that negative 2 out of the way. But when I plug in, I need to plug in with the negative 2 still there, because that's going to affect the sign of my answer. So when I plug in pi halves here, I'll have negative 2 sine pi halves. Okay, well, if you do hand trig, pi halves is your thumb. All the fingers are on the bottom, so it's negative 2 times 1. Negative 2 times 1 is negative. Other side, we're doing 3 pi halves. Negative 2 times the sine of 3 pi halves. Okay, well remember that the sine of pi halves is still 1, but I have to consider my quadrant. So if I look at my all students take calculus, okay, here's pi halves, here's 3 pi halves, because here's regular pi, right? So think about sine, in the tangent quadrant, sine is negative. In the cosine quadrant, sine is negative. Well then here, sine is negative as well. So that's actually a minus 1. And the product of negative 2 and negative 1 gives me positive 2. So what conclusion can I make? I have a negative concavity here. I have a positive concavity here. And that tells me that pi is, in fact, a point of inflection. So I would say I have a POI at x equals pi because f double prime changes sign. You can put the direction minus to plus, but you don't have to. Okay, one more example. The last one, number 5. Okay, f of x equals x squared plus 18 ln x. X squared plus 18 ln x. Okay, now your instructions are going to be find relative extrema and points of inflection. So, relative extrema tells me that I have to do the first derivative test. Points of inflection tells me I have to do the second derivative test. So, for this one, we're going to have to do both. Okay? So, get excited. Here we go. So, when I take the derivative, f prime of x equals, derivative of x squared is 2x, derivative of 18 ln x, remember the derivative of ln x is 1 over x, so it's 18 1 over x. Now, I can just rewrite that as 2x plus 18 over x. There's no point in me keeping these guys separate. 18 times 1 are both on top. They give me an 18. From here, hopefully you remember, we've talked about that this is not going to work for a line test. I have to make it one big fraction. So I'm going to multiply by an x both on top and on bottom. So now on top I have 2x squared plus 18. 2x squared plus 18. On the bottom, x and x, common denominator stays the same. Okay, from there I'm looking for my critical numbers. Okay, and typically with this guy we would be GCFing. Okay, however, I can't do that here. What you should notice is that 2x squared plus 18, even if I take the 2 out, actually let's do that just for me to demonstrate here. I get x squared plus 9. Okay, that is not factorable. Okay, now, in addition to the fact that it's not factorable, it's never going to equal 0. Think about the graph. That's a quadratic shifted up 9. So if I were to graph that, it's way up here. Okay, it's not ever going to hit 0. So that doesn't give me any answers, but x on the bottom does. So my only critical number is x equals 0. Then I set up my line chart. Okay, let's say I pick a number a little bit bigger than 0. Say I pick 1. 1 squared plus 9 is positive. Multiply it by 2, that's positive. Divide it by x equals 1, that's positive as well. So all positives means positive on the interval. Less than 0, say I pick negative 1. Okay, well then I'd have 2 times negative 1 squared. Well, negative 1 squared is positive, plus 9 is positive. Divide by my x we said is negative 1, so that's a negative. Well, plus plus minus, overall is minus. Now remember, this is f prime's sign chart, so that tells me if f is increasing or decreasing. So I know it decreases, then it increases. So that is a relative minimum. So I'd have relative min at x equals 0 because f prime changes negative to positive. Now, the other thing that I want to point out, just kind of like in general, is that if your equation asked, or if your question asked when f is increasing, or when f is decreasing, okay, you would be doing intervals, and I think we did a couple of these maybe last week, but just to reinforce. So f is increasing from 0 to infinity, and f would be considered decreasing from negative infinity to 0. Okay, so remember, you just be like choosing the part of the number line. Then your because for increasing is f prime is greater than 0. Decreasing, you'd say f prime is less than 0. So you're basically just saying this is the interval where it's positive, this is the interval where it's negative. Okay, now we're going to do the second derivative test. So we have our answers for min and max. We have one extrema. It's a minimum because f prime changed negative to positive. Now we're going to take the derivative again. Now, question. When I take the second derivative, f prime of x was equal to, I can use this, or I can use this. If I take the derivative of this guy, I'm going to need quotient rule. Quotient rule sucks. Okay, if you can avoid quotient rule, I would do it. So I'm going to come back to here, but I'm going to do a rewrite. So if I have a 2x here, that's fine. But then 18 over x is the same as plus 18x to the minus 1. So this is the exact same as this, but it's an easier place for me to take the derivative from than down here. Okay, so f double prime equals, derivative of 2x is 2, 18x to the negative 1 is a minus 18x to the negative 2. Then from there, I'm ready to rewrite that, so that's the same as 2 minus 18 over x squared. And then I look at that and I'm like, uh-oh, common denominator time. We cannot leave the 2 kind of separate off like that. So put in x squared here, put in x squared here. So my new f double prime is going to be 2x squared minus 18 over x squared. Then I notice on the top here I have a GCF. I can divide a 2 out. And I'm left with x squared minus 9, which I see then is factorable one more time. I can break that down into 2x plus 3, x minus 3, and then an x squared. So I take the second derivative, I get a common denominator, and then I factor the top, and I would factor the bottom if I could. So at this point, you should know that your PPOIs are going to be x equals negative 3 and 3 from the top, and then 0 from the bottom. Now, the other thing you should notice is that 0 here is a double root. And the double root tells me that I'm not going to have a sign change when I do my line chart. So negative 3, 0, 3. Pick a number bigger than 3. Maybe you pick 4. 4 plus 3 is positive. 4 minus 3 is positive. And 4 squared is always positive. So overall positive. Next one, say we pick 1. So 1 plus 3 is positive. 1 minus 3 is negative. 1 squared is positive. Overall, negative. Also, negative on the other side of 0 because 0 was a double root. I don't want to do extra work. Next, say I pick negative 4. Negative 4 plus 3 is negative. Negative 4 minus 3 is negative again. Negative 4 squared, though, is still positive. Then overall, my negatives on top cross out, turn that positive. Label your number line. These are the signs for f double prime. They tell me about f's concavity. They tell me f is concave up, down, down, up. So then I have POIs at 2 places, at negative 3 and at 3. So I would say POIs occur at x equals negative 3 and positive 3 because f double prime changes sign. Okay, Okay, the only other thing I could think about them asking is where f is concave up or down. Remember, you do it just like this. So f is concave up from negative infinity to negative 3, and it's concave down from 3 to infinity. Then it would be, I said that wrong. It's up here and here, and then it's concave down in the middle. Okay? All right, I'll see you tomorrow. Use your time wisely. You should still have about 15 minutes if you guys came in and got started pretty quickly. So have the best day. See you tomorrow.